everyone, welcome to the North American Math Content School. Today we're going to talk about this thing. Place number 1 to 9 such that each row column diagonal adds up to the same number. This is a 3 times 3 magic square, and we are going to talk about it today. So first of all, let's first talk about a thing. Why is each sum adds up to 15? This is something you are going to curious about, right? So let's try adding those numbers up. And the total cumulative sum, you can know is 45, right? And we see that there's 3 rows. If we place them, the total of 45 is the total is going to be 45. And there's 3 rows, but since each row must be equal, so therefore we can just simply divide it by 3 to know that it's 15. Next, we are going to talk about the total number of solutions. You should know that 3 times 3 magic square, it only has 8 possibilities, and all of them are the reflection and dilation of one puzzle. So I'm going to talk about all of the 6 pieces. So the first one is 8, 1, 6, 3, 5, 7, 4, 9, 2. I'm going to show you why it works. This adds up to 15. 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 And this adds up to 15. So it's like this. This is one of them. The another of them, 6, 1, 8, 7, 5, 3, 2, 9, 4. As you can see, this one is just simply a reverse rotation of the first one. This switches with this. The third one, 4, 9, 2, 3, 5, 7, 8, 1, 6, right? This one, you can see, it also adds up to 15, 15, 15, 15, 15, 15, 15, 15, right? So as you can see, this one is also a reflection of the first case, where this line is reflected with this. So 816 is reflected with 492 to produce the third one. For the fourth one is 294, 753, 618. Again, this one is also a reflection, but instead it's reflected twice. So row 3 is first reflected with row 1, and then column 1 is then reflected with column 3 to produce the fourth one. So just using this way, you can see that you are able to produce 8 and only 8 of them possibilities. The rest of the 4 are 834, 159, 672, 438, 951, 276, 672, 159, 834, 276, 951, 438. Those are the 8 distinct cases. You might be wondering why there is only 8 ways to prove them. Well, we are just going to talk about how to achieve that. So first of all, you must know that given number 1, 2, 3, 4, 5, 6, 7, 8, 9, there is only 8 distinct ways to sum to 15 in 3 numbers. Why do I specifically say 3 numbers? Because it is a 3 times 3 magic square. Each row only has 3 numbers. So the 3 numbers as up must be summed to 15. And I already said why it is 15, in the first few minutes. Now let's talk about the number of ways to sum to 15. The first way, 1 plus 5 plus 9 is obvious, and then it's 1 plus 6 is 8. Then it's 2 plus 4 plus 9. Please note that for the unique ways, the orders are matter. So this one and 1 plus 9 plus 5 are the same thing. Are the same thing. I consider one type. Then it's 2 plus 4 plus 9, 2 plus 5 plus 8, 2 plus 6 plus 7, 3 plus 4 plus 8, 3 plus 5 plus 7, and 4 plus 5 plus 6. So as you can see, there are 8 ways to form that, right? Now we are going to prove that the central number has to be 5, first of all. How do we prove that? As you can see, being a central number, it requires 4 lines, right? 1, 2, 3, 4. This means that there must be a number that the number in here must exist in 4 different equations. So as you can see, only 5 is this. 5, it has 4 times. So in this way, we can prove that the middle grid has to be 5. What we are going to do next is that we are going to prove that the corners are even numbers. How do we do that? What we are going to do next is we are going to prove that the corners are even numbers. How do we do that? So first of all, we can just see like being a corner, it requires 1, 2, 3 lines. Therefore, the number must exist in 3 equations. 3 equations. Okay? So the number must exist in 3 equations. So you can see, okay. So you can see that 2, it exists in 3 equations, right? 4, it also is in 3 equations. 6 is also 3 equations. 8 is also 3 equations. So it's 2, 4, 6, 8. It must be one of them. And also remember, this and this adds up. It must be equal to 10, because the sum adds up to 15, and this is 5. So 15 minus 5 is 10. So those 2 adds up must be 10. Those 2 adds up also must be 10. So as you can see, we can get 2 plus 8 is 10. 4 plus 6 is 10. So this means that we are able to produce ideal results. 2, 8, 4, 6. Type 1. Then it's 2, 8, 4, 6. Type 2. And then it's 8, 2, 4, 6. This is the third case, okay? And then this is the fourth case. Mm. 8, 2, 8, 2, 6, 4. So as you can see, we have 4 cases now. And you can also produce another 4 cases through the, what I told, the dilute, by putting the 6 and 4 in the right axis. 6, 4 here, 2, 8 here. Do you get what I mean? So this means that you have 6, 4, 2, 8, 5. Case 6 is 6, 4, 8, 2. Right? And then the 7th case is 4, 6, 2, 8. And the 8th case is 4, 6, 8, 2. And then it's like easy because then it's like forced. The odd numbers, they are just simply forced. So in this case, we can just use the rule that each row column diagonal adds up to 15 to solve the rest. Sorry, 9. This is the first case. 9, 3, 1, 7. 9, 3, 1, 7. 1, 7, 9, 3. 1, 3, 7, 9, 7. That's 1, 3, 7, 9. And then this type 9, 1, 3, 7, 3. This is 5. Never mind. 3, 1, 7, and 9. So those are the 8 distinct cases. Here we come to the end of our lesson. Hope you have enjoyed a lot. See you next week. Bye bye. In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow! In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!